a square grid on the board. Do you see it?
Yeah.
Do it up here too. So we see here. Now watch this. Watch what happens if I rotate this a little bit. See how it kind of twists around? What happens if I take this closer or further away, maybe? So this is illustrating the conformal mapping idea. See these? Well, yeah, the YouTube may not be able to see that, but that's okay. It's okay. I got something else. So what's going on there is this is actually what this is it's taking what these grid is if you take the grid on the complex plane of the Riemann sphere, and you take the grid on the complex plane, the orthogonal coordinate xy grid, and you map it back to the sphere. This is the inverse image of the horizontal and vertical lines on the plane. And so, you know, vice versa. These, if you look at these curves, they meet perpendicularly. So when you look at the projection onto the complex plane under the stereographic projection, they meet perpendicular. It's conformal. It's conformal. But there's so much more to say about this that I really can't do justice. But there is a video I just found before class, which I have got to show you guys because it's amazing. Hopefully I won't get a copyright strike. Probably not. All right. Ring. I know they say ring by spring, but if I teach complex here, it's usually ring by October.
Well, that happened for one of us.
Oh, come on. You're not going to play? So what you're looking at is what the Mobius transformation does to a little. All of these pictures are the mapping of the unit square under a Mobius transformation. In this case, translation, rotation. He did magnification already. These are the different. This is what happens to the unit square under a Mobius transformation. This is the image in the W plane. Well, I mean, how do you think all those like weird picture morphing filters work? It's this stuff.
What?
Oh yeah, it's about to get real. I mean, well, three-dimensional. Now you have worked out the algebra of this, but here's what it looks like. There it is, the Riemann sphere, the stereographic projection. I don't think we've done this math, but there's math that could be done here. Notice that the stereographic projection is creating all of the Mobius transformations that we saw at the start through just rotating of the sphere or moving of the sphere. Very cool. This video gives me shivers. It's just awesome. It's just, it's so cool. You guys should be making this kind of stuff in Mathematica. It should just be like one thing in the whole course, just a project to make this. As you can see, University of Minnesota, they make some really, really cool animations about various things like this. But in any event, well, I guess I'll finish class on time for once.
Dr. Good.
Yep.
The circle thing again?
The circle thing?